I was asked to come to Washington, and these two engineers and a psychologist, I call him a shrink, standing on the stage said, wouldn't you like to get in a rocket and a capsule on top of a rocket? There were about 70 of us in there. I said, I don't want to be part of that. That's silly. They finally, some people said, look, if you want to go higher, farther, and faster, let them talk to you a little bit more. The reason I accepted this challenge is the challenge was there. I wanted to go higher, farther, and faster. My first flight was Mercury. I called it Sigma 7. Well, that Mercury flight was up for a little over 9 hours, had 6 orbits, and I conserved the fuel. We had troubles with the first 2 flights using up the attitude control fuel. So I came back with almost 80% of that fuel, which is a pretty good mark, I thought. The next Mercury mission stayed up for over a day, so we proved the point that it could last that long. Now, people always say, what was the most beautiful view? And they expect me to say something about the Earth and the horizon. No, it was a parachute that came out so I could land. That was the most beautiful view. We always are asked the question, were you ever afraid? We had apprehension, a real play on words. Apprehension is not the same as fear. It means you know what's going on, but you're cautious. We were trained so well, over and over and over again, simulating everything that could possibly happen. When it became time to fly, or to take off, to be launched, we all said, at last, it's been taking so long to get ready.
Hello and welcome. This is Michael Annis, and you are listening to episode 35 of the Space Rocket History Podcast. And now, textbook Spaceflight, Mercury Atlas 8, Sigma 7, with Wally, Schirra. After Scott Carpenter's science-heavy Mercury Atlas 7 flight, NASA's next mission would concentrate on the technical and engineering aspects of space travel. Mercury Atlas 8 became the third manned orbital flight of the Mercury program. The pilot selected was Walter M. Schirra, Jr., but most people called him Wally. Schirra was born in Hackensack, New Jersey. He took his first flight with his barn-storming father at age 13 and learned to fly before he enrolled at the Naval Academy of Annapolis. After his 1945 graduation, Captain Schirra served with the 7th Fleet and flew 90 combat missions during the Korean War. He received the Distinguished Flying Cross and 2 Air Medals. Most of the time, Captain Schirra had a fun and effervescent personality. He was well known as a practical joker among the Mercury 7. In keeping with tradition, the astronaut pilot named his Mercury spacecraft. Wally decided to call it Sigma 7. Here's a clip of him explaining why he named it that.
Sigma 7 is a name to me that connotes an engineering symbol. It is the 18th letter of the Greek alphabet, and it also connotes summation. Basically, what we wanted to connote with this name was the very many inputs that have been brought forward to develop this flight. The fact that we had previous flights where we needed to make our initial steps into space. The fact that we had operations analyses of the previous flights, engineering analyses, that we had to make minor changes to make the previous problems of earlier flights straighten out. This, in truth, was the reason why I have been calling this Sigma, or engineering.
The Sigma 7 mission had 5 key objectives. First, evaluate the performance of the manned spacecraft system in a 6-pass orbital mission. Second, evaluate the effects of an extended orbital spaceflight on the astronaut and to compare this analysis with those of previous missions and astronaut simulator programs. Third, obtain additional astronaut evaluation of the operational suitability of the spacecraft and support systems for manned orbital flights. Fourth, evaluate the performance of the spacecraft systems replaced or modified as a result of previous 3-pass orbital missions. And fifth, evaluate the performance of and exercise further the Mercury Worldwide Network and mission support forces and establish their suitability for extended manned flight. Planning began for the mission in February of 1962, aiming for a 6 or 7 orbit flight to build on the previous 3 orbit missions. NASA officially announced the mission on June 27th, and the flight plan was finalized in late July. The mission was focused on engineering tests rather than on scientific experimentation. However, 4 science experiments were planned as part of the Mercury Atlas 8 flight. One was a light visibility experiment, similar to those conducted on the 2 previous missions. The second was a nuclear radiation experiment in which radiation-sensitive emulsions were used to study the flux and composition of galactic cosmic rays. Third was an investigation in which the ablation of various materials due to heating during re-entry was measured. The final experiment used a 70mm Hasselblad camera with various filters to gather imagery for assembling a catalog of Earth photography for comparison with similar images obtained by other satellite programs. The launch vehicle for this mission was, of course, an Atlas missile. It was modified since the previous flight and now included baffled fuel injectors and a new hypergolic fuel igniter instead of the original pyrotechnic igniter. This eliminated problems with combustion instability and allowed the booster to be released immediately upon obtaining full thrust instead of being held on the pad for a few seconds. There were also modifications to the Mercury spacecraft. Heating blankets were removed from the retro rocket motors to save weight, and a sound-fixing and ranging bomb was added. The bomb would be ejected at the time the main parachute was deployed. It would drop into the ocean and use explosive sounds to help recovery crews find the spacecraft after it splashed down. And finally, the reaction control system was modified to disarm the high-thrust jets and to permit use of the low-thrust jets only in manual operation in order to conserve fuel. Here's a clip of Schirra describing the modification.
Commenced the first flying phase of the flight, where I performed a fly-by-wire low turnaround. Fly-by-wire low only means that we have changed since John's and Scott's flight. We've added a switch to permit us to use the very low thrusters for maneuvering while in orbit. This made it much easier for me to handle. In Scott's case, he had a little more trouble with the high thrusters coming in frequently. This way we could cut them out, and I could concentrate completely on control and continue with other tasks simultaneously.
The communication system was improved by adding 2 high-frequency antennas mounted on the retro package to help maintain spacecraft and ground communications throughout the flight. There was additional instrumentation added and a suit temperature sensor to aid in correcting the previous suit temperature problems. Schirra began training for the mission in early July, logging 29 hours in simulators as well as 31 hours in the spacecraft itself. This included multiple system tests and 3 simulated flights, culminating in a 6.5-hour simulated flight on September 29th with the spacecraft and booster fully stacked on the pad. Highlights of the training period included a visit from President Kennedy on September 11th. The launch was originally scheduled for September 28, 1962, but various problems delayed the flight until October 3rd. On launch day, Schirra was awakened at 1:40 a.m. Eastern Time, and after a hearty breakfast and a brief physical, he left for the launch pad at around 4 a.m. Here's a clip of Robert Gilruth giving us some insight on Wally's mood on launch day.
With so much at stake, a little tension breaker is a big help. In this vein, as Wally emerged from the medical area in Hangar S to depart to the Atlas gantry, here he was all suited up and ready to go at 3 a.m. He said, "I didn't have much to do today, so I think I'll put in a little flying time."
Schirra entered the spacecraft at 4:41 a.m. Eastern Time, where he found a steak sandwich left for him in the, quote, glove compartment, and began the pre-launch checks. The launch countdown proceeded as planned until 6:15, when there was a 15-minute hold to allow the Canary Islands tracking station to repair a radar set. The countdown resumed at 6:30 and proceeded to booster ignition with no further delays. Liftoff proceeded smoothly, but at T plus 10 seconds, the Atlas began a sudden, unplanned roll, threatening a possible abort. However, after a few tense moments, the roll stopped as suddenly as it had begun. This was later identified as being due to a slight misalignment of the main engines and was kept under control by the booster's vernier thrusters. Here's the launch. Deke Slayton is the voice of Capcom.
5, 4, 3. I've liftoff, clock is started. She feels real nice. Completely good then for this flight? Yeah, I got the pins on my office wall. I'll turn it off the tank. At 5 or 20 seconds. Okay. 2, 1, start. Your backup started and running good. I'll give you a hack at my 30. Oh, she's riding beautiful, Dick. Mark 30. Okay, fuel is okay. Oxygen okay. All systems appear to go, and she's getting noisy.
The launch was relayed live via the Telstar satellite to television audiences in Western Europe. The booster cut off 2 seconds earlier than planned, but the sustainer engine burned for about 10 seconds longer than intended. Sigma 7 was inserted into a low Earth orbit with a perigee of 161 kilometers and an apogee of 283 kilometers. Initial analysis of the trajectory confirmed that the capsule could remain in a stable orbit for at least 7 orbits. At T plus 3 minutes 39 seconds, Deke Slayton radioed a strange message to Wally. He asked, "Are you a turtle today?" Here's the explanation. Turtles are bright-eyed, bushy-tailed, fearless, and unafraid folk with a fighter-pilot attitude. They think clean, have fun a lot, and recognize the fact that you never get anywhere in life unless you stick your neck out. It was started by a group of test pilots during the Second World War. The club has progressed to its present position as one whose membership is diligently sought after and highly esteemed by those lucky enough to be initiated. Adherence to the creed and always giving the password when asked for are the only responsibility placed on your membership. The correct reply for the question, "Are you a turtle?" is, "You bet your sweet A-word I am." It was not something Schirra could broadcast to the world below, but the penalty for not responding was having to buy all those listening a beverage of their choice. Wally very calmly announced that he was switching to the onboard voice recorder rather than the broadcast radio circuit to leave his answer. The mission communication transcript noted he gave the correct response. After separating from the Atlas booster, Schirra stabilized the spacecraft and slowly cartwheeled into the correct attitude. He deliberately kept the motion slow to conserve fuel and was able to position the capsule using only a half of 1% of his fuel reserves. Here is Schirra commenting at a post-flight press conference on the fuel-saving maneuver.
We needed to find out how long the control fuel would last. In both John's case and Scott's case, we were fairly low on fuel, but we didn't have the high reserves that we were trying to put on my flight. We only wanted 3 orbits. There was enough fuel for 3 orbits. They had enough, obviously, to complete them, or I wouldn't have been able to introduce them to you today. My intention was to use so little fuel that no one could argue that we had enough fuel aboard Sigma 7 for 18 orbits if we wanted it. I think I proved that point.
Crossing over the eastern coast of Africa, Schirra began to feel the overheated suit problem, just like Carpenter and Glenn had experienced. The problem was also apparent to the ground controllers, who were having a debate with the flight surgeon over whether it was safe to continue or if the mission should be ended after the first orbit. The flight director, Christopher Kraft, followed the surgeon's advice to see if the problem would settle and gave the go for a second orbit. Over Australia, Schirra watched for flares launched from the ground, but it was covered by clouds, so he was unable to see that. He was able to see lightning and the lit outline of Brisbane. Through the night pass over the Pacific, Schirra tested the capsule's onboard periscope, though he found it difficult to use and quickly covered it up as soon as the sun rose. Crossing over Mexico, he reported that he was in, quote, chimp configuration, which meant the capsule was running entirely on automatic without any input from the pilot. Schirra began his second orbit by testing a yaw maneuver using the Earth through the main window as a reference. Schirra also confirmed the existence of Glen's fireflies. Here's the clip.
The fireflies, as John described them, were perfectly described. The coloring was the light green that you can see on a summer evening on an open field. The white, frosty type articles, as Scott described them, including the lathe turning, I saw one of those, Scott, were exactly as you described them. I had a chance to evaluate both. My own opinion is, and it's going to take another one, to come up with a series of opinions on this, was that they were from the capsule. I don't know whether we'll see them on future flights. I know we'll see them on future Mercury flights. Whether the same chemicals, the same byproducts of control or cooling are with us in future vehicles, I'm sure we'll have some new reports on fireflies and white objects. At any rate, they are there.
Schirra was also able to stabilize the suit temperature problem by slowly dialing the suit's control knobs to a high cooling setting. Here's the clip.
I believe that some people thought we were having a suit problem. The cool analysis on the surface in Mercury Control Center while in an air-conditioned room obviously gave me the opportunity to pursue the chasing down of the proper coolant quantity flow to bring the suit under control. And this is what we did.
Sigma 7, this is Colonel Capcom transmitting on UHF HF. Do you read? Over.
Roger, Colonel Capcom. Do you read me? UHF low. Over.
Roger. Stand by this frequency 7 for Capcom.
Okay.
How's your suit temp doing now?
It looks like it's holding, huh? Let it sit for a while.
All TM system good, 7.
Roger, I think the only problem I have is the suit circuit. I'll work on it for a while and see how we are.
Takes a wee bit of time for that to stabilize.
Right, that's what I'm trying to do. Duke, I finally got a grasp on this thing where I'm beginning to feel a little cooler, and the suit inlet temperature is now down to 7.6. Over.
As he began the third orbit, Schirra disconnected the spacecraft's gyroscopes, turned off part of the electrical power system, and let the capsule drift. A considerable amount of attitude drift time was built into the Sigma 7 flight plan in order to study fuel conservation methods. This included 18 minutes during the third orbit and 118 minutes during the fourth and fifth orbits. The result was that 78% of the fuel supply remained at the start of re-entry. Later in the third orbit, Schirra received approval for 6 orbits. He then took advantage of the quiet period to test his spatial awareness and motor control, which he found was broadly unaffected by weightlessness, and he had a light meal. He powered the spacecraft back up over the Indian Ocean and continued over the Pacific. As he crossed over California, he shut down the electrical power for a second period of drifting flight, during which time he occupied himself with taking photographs. Here's a post-flight clip of Schirra describing the photography of the mission.
We had requirements for terrestrial photos, looking at various land masses to see if they might show something that might help us for analysis of the surface of the Earth, and possibly to extrapolate it for other planets. In addition, the Weather Bureau wanted to confirm what type of filter would be best used for the Tyros and Nimbus vehicles. As a result, I carried a black and white back on this camera with 5 different filters, all in a row, all shooting simultaneously. In other words, there were just 5 strips in a plane. These filters will help us determine which filters to use for weather observation satellites.
On the 5th orbit, Schirra used a small bungee cord exercise device for a little bit of stretching. Over the Atlantic, he returned to observation and photography. He was unable to spot the planned high-powered light near Durban in South Africa due to cloud cover, but he did make out the brightly lit city of Port Elizabeth. Over the Philippines, he reported on his fuel status. After 4.5 of the planned 6 orbits, he still had 80% remaining in both manual and automatic tanks. Passing over Quito, Ecuador, towards the end of his 5th orbit, Schirra was asked by the tracking station if he had any messages to pass on, in Spanish, to fellas down here. And he made some comments on how beautiful the country appeared from orbit, ending with a cheery, "Buenos dias, y'all." Schirra spent most of the 6th orbit preparing for re-entry, but he was able to take a last set of photographs of South America and try another set of spatial orientation tests. He armed the retro rockets as he passed over the Western Pacific. Retro 1 was fired at T plus 8 hours and 52 minutes. Here's the clip.
Oh boy, she's a good little capsule, I'll clue you. Here you go. Roger. 5, 4, 3, 2, 1, 0. I got one. And she's holding real tight. Very tight. I got 2. The other 2s are right on the money. I got 3.
Emergency retro jettison fuse switches on.
Roger. They are on. Retrojet is on. Got sunlight. Everybody's very happy. I'm going to fly by wire, Al, to pick up the re-entry attitude. Manual is going in.
And we're showing you have about 6-8% auto and 8-4% manual fuel left. I think our readings are about.
I got 6-8 auto and 7-8 manual. Standing by for retrojet. I have retrojet and light is green. I could hear it, by the way.
Very good. We confirm retrojet.
In contrast with Scott Carpenter's flight, the automatic control system worked correctly and held the capsule steady during retro fire. However, it did burn almost a quarter of its fuel in the process. The recovery forces waiting in the Central Pacific consisted of an aircraft carrier, the USS Kearsarge, in the center of the landing area, with 3 destroyers strung out along the orbital path. 4 search aircraft were also assigned to the area, and 3 recovery helicopters were based aboard the Kearsarge. The Kearsarge picked up the capsule on radar while still 320 kilometers from landing. 140 kilometers further up the landing path, the destroyer, USS Renshaw, reported a sonic boom as it passed overhead. At 12,000 meters, Schirra deployed the drogue parachute and then the main parachute at 4,600 meters. The landing was surprisingly precise, 7.2 kilometers from the target point and only 0.8 of a kilometer from the Kearsarge. And Schirra joked that he was on course for the recovery carrier's number 3 elevator. The capsule hit the water, sank, and bobbed to the surface again, righting itself after about 30 seconds. 3 pararescue swimmers were dropped by one of the helicopters to help Schirra climb out of the capsule, but Schirra radioed that he would prefer to be towed to the carrier and remain in the capsule. Here's the clip.
Looks good. Got 55% auto fuel. Passing through 70,000 feet. 65,000. Attitudes are very stable. Coming up on 60. Big command doing very well. Coming up on 50. She looks like a sweetie. Coming up on 45,000. And down to about 1 G. preparing to punch the drogue at 40, 31, punching drogue, and the drogue is out. You can hear, I can't see it because of the clouds. Attitudes are holding well, and your lever is in. ISGS fuel is going pretty fast. I can see the drogue now. Drogue looks very good. I'm doing oxidant to, actually I don't need it. Big command is burning itself out, and the oxidant is doing nothing, just sitting there. I'll put it in auto mode just to let it pump out. Roger, I'm coming down on 20,000, standing by for snorkel, and pressure is increasing. Snorkel should go. I believe snorkel is blue. I felt them. I will pull it anyway. Have emergency rate. I think I led the snorkels a little bit on that one. And dumping H2O2. Switch fuse on. Standing by recovery arm is armed. Standing by for main chute. All switches in proper position. And your fuel is almost all gone. There goes drogue, and main is out, and oh, she's out beautiful. Nice blue sky. Main is de-reefed, and looks like a sweetie pie. I feel marvelous. This is a beautiful flight, wasn't it?
And here's the clip for the pickup.
Hey, Roger, Swiss One, this is Astro. How are you today?
Fine. I got you on Berkov. Give me a short count, please.
Roger, short count follows. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. This is Astro Sigma 7. Very happy to be back in the Pacific Fleet.
Okay, Astro, the swimmer's in the water.
Roger. Howdy, fellas. They know I'm all right, I assume. I heard them knock on the capsule.
Astro, this is Swiss pilot. The carrier is about 3/4 of a mile. Closing.
Okay, fine. I frankly would prefer to stay in and have the small boat come alongside, using your collar routine, of course, to support me, and having a ship pick up. Over?
Roger, understand you want ship small boat, so give them that word right away.
It took about 40 minutes to get Sigma 7 on board the Kearsarge. 5 minutes later, Schirra blew the explosive hatch and climbed out. After doing this, examinations showed clear bruising on Schirra's hand from operating the heavy ejector switch, which Schirra felt provided an important vindication for fellow astronaut Gus Grissom's hatch-blowing accident during the Liberty Bell 7 mission. Grissom had maintained that the hatch blew without his input. The fact that Grissom had no bruising was seen as evidence that he had not blown the hatch early and sunk his capsule, but that it was a mechanical malfunction. Now here's a clip of Wally Schirra summarizing the mission.
As the dust and debris settled from the hatch departure, I stepped out on the number 3 elevator and requested permission to come aboard. This is a novel way for a carrier aviator to come aboard a carrier. I think the most exciting thing for me in the flight was to realize that I had proven, and that the capsule itself has proven, that we could go beyond 3 orbits. We had initially stated and felt very strongly, even as far as the way the flight plan was worked out, that we would get enough information from the 3 orbits to justify the flight. The additional 3 orbits were frosting on the cake. I believe it's about that time that I said hallelujah, and that is when I was excited to realize that we had control of the systems, that we had good control of the capsule, that I had good control of myself, that physiologically I was in good shape to continue, and we were on the way to 6 orbits.
The post-flight analysis reported no major malfunctions, the only troublesome anomaly being the suit temperature controls. All the engineering objectives of the mission were met. The fuel conservation measure worked particularly well. The medical analysis found no significant physiological effects from 9 hours of weightlessness and noted that Schirra had received no significant dose of radiation. The radiation-sensitive emulsion test was successful. However, the light observation experiments were not successful because both targets were covered by thick cloud cover. The filtered photography for the Weather Bureau worked as planned. On October 16, 1962, Schirra visited Washington, D.C. to receive the NASA Distinguished Service Medal from President Kennedy. Here's how Wally remembered it.
After my Mercury flight, I went to the Oval Office where President Kennedy was with my wife, my son, and my 5-year-old daughter. Before I got there, I was escorted to the office by Bobby Kennedy, President Kennedy's brother. And Bobby said, "Come on, Da, we are interested in your political affiliations," trying to imitate the Boston accent. And I said, "Well, Mr. Kennedy, I think you are confused. I'm an engineer, something of a scientist. All of my comments, all of my decisions are based on fact. I find the transition to politics impossible."
All told, Sigma 7 completed 6 orbits, landing 440 kilometers northeast of Midway Island in the Pacific. The duration of the flight was 9 hours, 13 minutes, and 11 seconds, during which time Schirra traveled over 230,000 kilometers. Schirra proved that an astronaut could carefully manage the limited amounts of electricity and maneuvering fuel necessary for longer, more complex flights. The capabilities of the Mercury spacecraft were confirmed as well, and allowed NASA to plan with confidence for a day-long Mercury Atlas 9 mission, which had been an early goal of the Mercury program. The public and political reaction was muted compared to that of earlier missions, as the Cuban Missile Crisis soon eclipsed the space race in the news. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.